Okay, we're picking up day 2 of the rational roots theorem. This is part of the polynomials unit, or the fundamental theorem of algebra unit. My favorite unit to teach in college algebra. It's not even close, as I've said before. So we're going to do one that's a little bit of a review. We're going to pick up exactly where we were yesterday. We're going to do problem number 4 at the bottom. Problem number 4 at the bottom. So let us review together. Okay, let us review our efforts here. This polynomial right here, to your knowledge, does it look like it factors? Doesn't look like it, but it turns out it does. We're going to discover a way to factor it. A lot of people don't like this method because they're like, oh, it feels like we're just guessing. Yes, but we're making excellent guesses. So it factors to 3 parts. Why? Because it has degree 3. In order to help to figure out some of those factors, I look at my P's and I look at my Q's. Do my P's come from the 4 or the 3? They come from the 4. So my P's are? My Q's are? Very good. So in order to come up with your choices, you take your P's divided by your Q's. So, I asked somebody how they like to do this. Do they like to take just one of the P's and divide by each of the Q's? Or do they like to take all the P's and divide by one of the Q's at a time? One at a time. And they said to start with the 1 and divide by the 1 and the 3. That's what they like to do, they said. Kaylee's going the other way. Okay, I got you. Okay, so we'll do that. 1 divided by 1 is 1. 2 divided by 1 is 2. 4 divided by 1 is 4. So I've taken care of the Q value of 1. Now I'm going to move on to the Q value of 3. Plus or minus 1/3. Plus or minus 2/3. And plus or minus 4/3. 1/3. 2/3. 4/3.
Oh, I meant like 1/1 and then 1/3 and then 2/1.
So you could do that too. So Kaylee didn't like that idea, so then you would get this. You get 1 and 1/3, then you get 2 and 2/3, then you get 4 and 4/3. So either way is fine. We allow you to choose however you will. Okay, so what would you like to choose first? Do you want to choose one of those fractions? Me neither. I don't like it. What do you want to choose? 1. Let's try it. 1 cubed times 3 is 3. 1 squared is 1 times 10 is 10. 9 times 1, negative 9, negative 4. That makes 0. So did 1 work? So what's my factor? X minus 1 is the factor. So I take the 1 and I divide it through using synthetic division. Talking with Miss Hanson at lunch, she said she loves synthetic division so much that she could just do 2 straight hours of problems of it. So what I want somebody to do here is to find a worksheet online and then bring it to her and say, here, Miss Hanson, here's your Christmas gift. So the factor is x minus 1 times 3x squared plus 13x plus 4. Are there any questions how I got that far? Now, here's the question and confusion that came up third hour. They said, Mr. Gens, well, how do we know when we stop doing that? If some of you guys have moved further along in your assignment, you find that sometimes you do it multiple times. Look at what we've come up with. We've come up with x squared. We have 2 ways of solving x squared equations. What is one way? Quadratic formula. The other one is a factor, right? So every time you get an x squared, you say, yay, quadratic formula or factor. But if it was x cubed or x to the 4th, then we would have to do this process over and over again. Okay? So, does that factor? It sure does. My good friend Marissa tells me it factors to 3x plus 1 times x plus 4. So I have solutions of x is equal to? Good. If I wanted a graphic, could I? Yep. Are those part of my choices? If they weren't, I made a mistake. Flip it over, last problem, and then you'll have time to work. What is different about this example? So we're going to go x to the fourth in this situation, okay? The degree is 4, so there should be 4 factors. Would you agree that p's are all the factors of 48?
Yep.
And the q's are factors of 1? So I'm not going to list all the p's there. I'm just going to write them with my choices instead of doing it twice, okay? So factors of 48, plus or minus 1, plus or minus 2. Help me out. 3, 6, 8, I heard 12, 16, 24, 48. Ooh. Yeah. Yeah. Okay. So some important elements coming up in this problem. It's not as simple as just doing the problem. Some things I have to communicate to you during this time. First of all, what number would you like to plug in? 1. And as you plug in 1, notice what happens. As we plug in 1, we get, 1 to the fourth is 1 plus 7 plus 8. That looks good. But then I subtract 28 and 48. Do you think that's going to give me 0? No. And I don't know about you guys, but I'm pretty good at plugging in 1. I'm not as good as plugging in things like -2. You know what I'm saying? So if 1 didn't work, what do you want to do? You want to try -1 or do you want to try +2? +2? Okay, so we'll try 2. Now to be clear, does everybody understand they can make a mistake plugging in 2? Can I show you how to avoid the mistake of plugging in 2? Avoid the arithmetic error. I find instead of plugging it in, if I just run 2, right now, if I just try running it through synthetic division, if it works, what should the remainder be? 0. So I'm a lot less likely to make a mistake doing this. -28 plus 52?
No.
24. 48, 0.
Yes.
Did 2 work? Do you see how I'm less likely to make a mistake doing that, and I might be more likely to make a mistake if I plug in 2? And some of you guys are like, well, I'd be fine with 2. Well, how about -3? How about -1/3 if that came up? Do you see how running it through synthetic can actually help you? We actually call it synthetic substitution. That's the mathematical term for it. So 2 works, so what's the factor? X minus 2. What do you notice about all my terms here that I have left? They're all, so I have x to the third plus 9x squared plus 26x plus 24. What do I not want to try? Like, should I try 2 again? Why? They're all positive. Does everybody agree that I'm going to have a negative number to make this work? There's no way that a positive number works out. So you could try 2 again. It might be a double root, but we can see right now no positive numbers are going to work. Here's a piece I want to refer you to so that you understand where we're at. Turn to the very last page that you have, the very final page that you have in your notes. It should look like this. This is where we started in this problem. We identified the number of roots as 4, correct? And then we looked at it and said, does it factor? If it does factor, use one of these factoring methods. This is what you've learned over time. Here's some notes for you if you forget how to factor, like sum or difference of cubes, or trinomials, or grouping, or things like that. There's examples laid out for you. But if it doesn't factor, that's where you have to use the rational roots theorem, which is what we're using. We find our p's and our q's. We found one that works, and we divided it. Look, is the degree of the new polynomial 2? Is the degree of our new polynomial right now 2, or is it 3? It's 3. If it's greater than 2, if it's 3, we got to start over and do it again. If it is 2, then you can factor or use a quadratic formula. So you guys are right here with me going through this process saying, we got to try another number. And you know that 2 doesn't work. So what do you want to try? Okay, let's try negative. Did I hear -2? Let's try -2. And I throw these across the top. 1, 9er, 26, 24. Drop the 1 down. Multiply. add, multiply, add, multiply. So x minus 2 worked. What's the other factor that works? X plus 2. So it turns out I've got a factor of x plus 2 times x minus 2 times x squared plus 7x plus 12. Does x squared plus 7x plus 12 factor to what? So what are my solutions? Are those all part of my choices? They are. It's pretty nice, huh? If we wanted to graph that, could we? And I just want to end by saying two things. Number one, you looked at this from the beginning and you said to our known ability, it doesn't seem to factor. Were we able to factor it? That should impress you a little bit. Second thing I want to convey is this. Things I wrote.